This is lesson 3.4, exponential and logarithmic equations. You're going to apply the one-to-one property of exponential functions to solve equations. And then you're also going to apply the one-to-one property of logarithmic functions to solve exponential and logarithmic functions we're going to solve. So, the basis for solving exponential equations is that if the bases are the same, then the exponents have to equal each other. So that's the basis for all that we're going to do. So when I look at this, I see that it's 4x plus 2, 16x minus 3. The bases aren't the same, but I know that I can take the 16, and 16 is 4 times 4, which is a 4 squared. So then I have 4x plus 2 equals 4 squared, parentheses x minus 3. Since the bases are now the same, they're gone, and I can solve the resulting equation. X plus 2 equals, I'm going to distribute the 2x minus 6. So this is going to be an 8 equals an x. All right, this next one, I've got a 1/3 and I got a 1 over 81. A larger number usually gets broken down into smaller, so 81 is 9 times 9, and each of these 9s are 3 times 3. So 81 is 3 to the 4th. So I have 1 over 3 to the n, and then I have 1 over 3 to the 4th to the 2/3. Now, what do I do with that 4th? The question becomes, where do I need to keep it as a positive 4, or do I need to make it a negative 4? And that all has to do with where the 3 is supposed to be at. The 3 is still in the denominator, so it's just a regular 4. So this is a 1/3 to the n equals 1/3 times 4 to the 2/3. The bases are the same. I get n equals 4 times 2/3. So n is equal to 8/3. Let's solve some logarithmic equations now. So the point of these is to always solve for the log first. So solve for log. Whatever it is, if it's a natural log, if it's a common log, if it's a log base 10, log base 5, solve for the log. So first things first here is I need to divide by 2. I get the natural log of x equals 9. And then you always ask what undoes a log. What's the inverse of it? So the inverse of a natural log is a base e. So this is going to be x equals e to the 9th. And you punch that in your calculator, and you get that it's approximately, because it's not exact, 8,103.08. So the next one here, I've got to solve for this log. So I need to move everything else over first. So I'm going to subtract 7. Negative 3 log of 10x is equal to a 6. Divide by the negative 3. Log 10x equals a negative 2. So the next thing I need to ask is, well, that's a log base what? Well, there is no base number there, so it's a base 10. So I need to put a base 10 on each side. That'll cancel it out. This is a 10x equals 10 to the negative 2, which is really just 10 to the negative 2, a 0.01. And I divide by 10, get x is equal to 0.001. Last one here. Here's my log, and it's a log base 5, so I need to take a base 5 on each side. That'll cancel out. Got x to the 4th is equal to 5 to the 20th. 5 to the 20th is a really large number. But how do you get rid of that 4th power? I need to take the 4th root. So I'm going to do this all at once. Well, actually, I'm going to do this. Say x is equal to 5 to the 20 over 4. That'll make it easier. So this is going to be x to the, x equals 5 to the 5th. And 5 to the 5th That's a much nicer number. You can handle that one, 3,125. These are a little different. Notice it's not just one log. There's logs on both sides. And so in order to solve these, you have to get a log base equals a log base. You can't have anything else. So this one is a subtraction to start with. Because it's subtraction, remember, in order to combine subtractions, you divide. This is going to be a log base 2 of 5 equals a log base 2 of 10 over x minus 4. Now it's a log equals log. I can drop the log from both sides and get 5 equals 10 over x minus 4. And then I can cross multiply. There's 1 down here. So it's 5 minus 4 equals 10. I'm actually going to divide by the 5. So x minus 4 equals 2. So x equals 6. Done. Next one, it is a log base 5 equals a log base 5. So I can cancel those out. They're gone. I have x squared plus x equals 20. X squared plus x minus 20 equals 0. Factoring it, it's an x plus 5. X minus 4 equals 0. So x is equal to negative 5 or 4. All right, looking at these, there's no logs. Okay, I can't make the bases on each side the same because we have a 3 and a 7. There's no way to break those down into the same thing. So when we have a situation like this, we need to solve it by putting a log on both sides. It can be a common log, it can be a natural log. It doesn't matter which one as long as you do the same to both sides, unless right here we see this e, and then we have to do a natural log. So I want to put a common log on both sides. So this is a log, base, common log, so base 10 of 3 x equals log of 7. And you learned that if it's an exponent, it's going to go up, multiply. And the log of 3 and log of 7 is the same. By log of 3. And I get x is equal to log of 7 divided by 3, which is approximately equal to 1.7. All right, next one. See the e base, base e, so that tells us we have to use the natural log, an ln. Natural log on both sides. This cancels out. I'm left with 2x plus 1 equals natural log of 8. Now remember, this is just a number. It's going to be an irrational number, but it's just a number. So minus 1, got a 2x equals natural log of 8 minus 1. Now that is not the natural log of 7, okay? Do not subtract into the natural log. It doesn't work. And then divide by 2. And x is equal to the natural log of 8 minus 1 over 2. So you put that in your calculator, and you get that x is approximately equal to 0.54. Next one. This one's a little bit like the first one over there, but we've got a much more complicated expression in the exponent. But in order to get rid of the base, we still have to take the log of both sides. So this is going to be log of 3, 6x minus 3 is equal to the log of 2 of 4 minus 4x. Now remember, your exponent is going to come out front. I get a 6x minus 3 is equal to log of 3, or times the log of 3 equals the log 2. And I could have put it out front, but I want to go ahead and put it behind. 4 minus 4x. So this is just a number, all right? Still just a number. It's just a little bit more complicated. because we have to carry it around. So I'm going to distribute here and on this side. Actually, let's not do that. Let's go ahead and divide so I don't have to deal with it on both sides. So I'm going to divide by the log of 3 so that I don't have to deal with logs on both sides. So now I'm going to distribute log of 2 over log 3 times 4 minus log 2 over log 3 of 4x times 4x. All right, so let's see what log 2 divided by log 3 is. For some reason 3 is not down there in the bottom on either one of them. So log 2 divided by log 3, that's approximately 0.6309. So 6x minus 3, and multiply that by 4. So 2.5237 minus 2.5237x. So I'm going to add this. And then I'm going to add my 3 to both sides. 8.5237x equals 5.25, sorry, 5.5237, and then divide that by the 8.5, and then I get x is approximately 6.5. All right, let's try this one. This is actually quadratic form because this is a base e to b this, and it's a 2, a 1, and a none. So we're going to do something called substitution. We're going to make the base e to the x. We're going to go, well, that's u, so this is going to be a u squared minus u minus 2 equals 0. The factors of negative 2 that when added together give you a negative 1. That's going to be a u minus 2 and a u minus 1 equals 0. And so I get u equals 2, u equals 1, but we're not done because we're solving for x. U is equal to e to the x. So I'm going to go and plug my e to the x back in. E to the x equals 2, and e to the x equals 1. So take the natural log of both sides, and I get x is equal to 0.69 on this one, and then on this one x equals 0. Well, we want to check, and the only solution that works is this, because this is an extraneous. It won't work when you plug it back in. Yeah, that's how you do that. Let's do 2 more problems real quick. Remember, it's a log has to equal a log since they're all logs. And how do we combine addition? I combine it by multiplication. And once a log equals a log, as long as it's the same base, we can cancel it out. This is an x squared minus 3x. Move the 28 over, minus 28 equals 0. When we factor it, factors of a negative 28 when added together give x minus 7 and x plus 4. So x equals 7, x equals negative 4. You always have to plug back in and see if they work. This one doesn't, so our answer is x equals 7. Last problem. In order to do this one, we're going to put our logs on both sides. because it's not, every term does not have a log, so you've got to combine all your logs over on one side, and anything else goes to the other. It doesn't matter which side as long as they're on opposites. And then subtraction combines as division. 3x minus 4 over 2x plus 3 equals 1. And we need to replace 10 to both sides. So at 3x minus 4, 2x plus 3 equals 10 to the first, which is 10. So I'm going to cross multiply. I get a 3x minus 4 equals a 20x plus 30. I get a negative 34 equals 17x, and then negative 13 x equals negative 2. Plug it back in and check and see if it works, because it does not, and there is no solution.